All right, ready to dive in. Today, we're going deep into the ocean, that is, with oceanography.
Oceanography. Yeah.
And, we've got some pretty fascinating material to work with here. Different ways, all the different ways scientists study this, this massive, mysterious world.
Yeah.
We're going to be talking about geological oceanography,
Okay.
paleoceanography,
Right.
marine geology,
Uh-huh.
and marine ecology.
Sounds good.
It's amazing, how much we can learn about the planet just by studying what's beneath the waves.
Absolutely. I think a lot of people don't realize
Yeah.
how much is down there
Right.
and how much it can tell us.
So let's start with geological oceanography.
Okay.
I was reading that it's not just about what the ocean floor looks like, but how it's constantly changing.
Yeah, that's one of the things that makes it so fascinating, right?
Yeah.
It's not just the static environment. It's constantly evolving.
And we can actually measure and see these changes
We can.
using things like sonar.
Yeah. Sonar is amazing. It's how we map the seafloor, essentially,
Right.
sending sound waves down.
Yeah.
And they bounce back and tell us what the shape of the ocean floor is like.
And it's incredible what they're finding.
Oh, absolutely.
I was reading about the Mid-Atlantic Ridge.
Oh, yeah.
That's a mountain range under the Atlantic Ocean.
Right.
Longer than the Andes, the Rockies, and the Himalayas combined.
You're right. It's massive.
It's just mind-boggling.
It's all underwater.
You just can't even picture it.
Yeah.
I remember learning about plate tectonics in school,
Mm-hmm.
but I never really put it together how much it really impacts the ocean.
Oh, it's the driving force behind everything.
Right.
Plate tectonics, those massive plates are constantly shifting, creating new ocean floor, causing earthquakes, forming underwater volcanoes.
Right.
It's a dynamic process that shapes the entire planet.
So you mentioned volcanoes. That's
Yeah.
one of the things I was really curious about. Those hydrothermal vents,
Oh, yeah.
I keep hearing.
They're amazing.
They're like from a science fiction movie.
Yeah, they kind of are, right?
Yeah, there are these openings in the seafloor
Right.
where superheated, mineral-rich water
Yeah.
just spews out.
Yeah.
Constant.
It's like geysers, but underwater.
Yeah.
And it's under immense pressure.
Yeah, and it's so hot.
Super hot.
But what's incredible is that there's life around these vents.
I know, right?
Entire ecosystems
It's mind-blowing, isn't it?
that exist without sunlight.
Yeah, they don't rely on photosynthesis like most life on Earth.
Right.
They use chemosynthesis.
So no need for the sun at all.
Nope, they get their energy from the chemicals in that hot water.
Oh, it really changes how you think about life.
Yeah, doesn't it?
Makes you wonder what else might be lurking in the depths of the ocean.
Exactly. There's so much we don't know.
So much more to discover.
And that brings us to paleoceanography,
Okay.
the study of the ocean's past.
Like looking back in time.
Yeah, kind of like being an ocean detective. Scientists analyze things like sediment cores, which are basically like time capsules of the ocean floor.
So they can actually like drill down and get these cores.
Yeah, they use special ships and drills to extract these long cylinders of sediment,
Right.
and each layer represents a different period of time.
So they can see how the ocean has changed over millions of years.
Exactly. It's like reading the history of the ocean layer by layer.
And what kind of things have they discovered? Any big surprises?
Oh, plenty of surprises. But one finding that's really relevant to us today is the rate of ocean acidification.
Yeah, that's a big one.
By studying ancient plankton in those sediment cores, they've shown that the ocean is acidifying faster now than any time in the last 300 million years.
300 million years.
That's a long time.
That's a long time.
And it's a major concern because ocean acidification can have devastating effects on marine ecosystems, especially coral reefs.
Yeah, those are really sensitive to changes in pH.
Yeah, they are.
It's amazing how we can learn so much about the present by studying the past.
Absolutely. It gives us a much broader perspective.
All right.
Understanding those long-term changes can help us predict and hopefully mitigate the impacts of climate change on the ocean.
So speaking of impacts, that's where marine ecology comes in, right?
Exactly.
It's all about the relationships between marine organisms and their environment.
Right. It's the study of how everything interacts in the ocean,
Right.
from the tiniest plankton to the largest whales.
Yeah. And how they're all connected.
Exactly.
How we impact them.
Yeah. Marine ecologists are on the front lines of understanding how human activities like pollution and overfishing are affecting the delicate balance of marine ecosystems.
Because it's a balance, it's all connected.
It is.
And if one part of that ecosystem gets disrupted,
Yeah.
it can have ripple effects throughout the whole system.
Absolutely. It's all interconnected.
Their research is crucial for developing strategies to protect our oceans.
It is. We need to understand the problems before we can find solutions.
So from mapping massive underwater mountain ranges to uncovering ancient climate records
Yeah.
and studying the effects of pollution,
Right.
oceanography is a pretty diverse field.
It is. There's so much to explore.
It really is.
And it's all connected.
Yeah.
Plate tectonics shape the seafloor, which
Right.
influences the ocean's history,
Uh-huh.
and the ecosystems that thrive there.
Right.
Everything is interwoven, and understanding these connections is key to ensuring the health of our oceans for future generations.
And I think that brings up a really important point,
Yeah.
that studying the ocean is not just about satisfying our curiosity.
Right.
It's about understanding our planet
It is.
and protecting it for the future.
Absolutely. The ocean is vital to our survival,
It really is.
and we need to do everything we can to protect it.
It really highlights how much we still have to learn
Yeah.
about this vast, mysterious world beneath the waves.
There's a whole universe down there.
So what aspect of oceanography has you most intrigued?
Oh, that's a tough one. I'm fascinated by all of it, but I think the deep sea is particularly captivating. There's so much we don't know about what lives down there.
Yeah, it's like exploring another planet.
Exactly. And who knows what incredible discoveries are waiting to be made,
What new forms of life might be lurking in the darkness.
or what ancient secrets are buried in the sediments.
Yeah, there's a whole ocean out there to explore.
It's exciting, isn't it?
It is.
The possibilities are endless.
Yeah,
And the more we learn, the more we realize how much more there is to discover.
absolutely. So much more.
It's a constant journey of exploration.
Yeah, and I think that's what makes it so fascinating.
It definitely does for me.
Yeah, I think it does for a lot of people.
And hopefully for our listeners as well.
I hope so.
It's a world worth exploring
It is.
and a world worth protecting.
It is well said.
Thank you.
And on that note, we'll wrap up this deep dive.
Sounds good.
But I encourage you all to keep exploring,
Yeah, keep learning.
keep asking questions,
And keep the ocean in your hearts.
because it's a truly amazing place.
It is.
Thanks for listening.
Thanks for having me.
And until next time, happy diving.
Happy diving.
Bye.
Bye.